This is a fully dynamic AAA crosshair, and it spreads as you walk, sprint, and jump before snapping smoothly back to the center. The whole thing is completely modular and built with blueprints only, so it drops onto any character in just a few minutes. Let me show you how to build it. Let's get into it. Head over to the content drawer, right-click, and create a new structure. Name it st_crosshair state, then open it. Rename the first variable to current spread and set its type to float. This variable stores the current spread value of the crosshair. Create another variable named isVisible and set its type to Boolean. This variable controls whether the crosshair is visible or hidden. Make sure the default value is enabled by ticking the checkbox. Next, return to the content drawer, right-click again, and create another structure named st_crosshair style, then open it. This structure contains all of the visual settings for the crosshair. Rename the first variable to line length, and set its type to float. This value controls how long each arm of the crosshair is. Create another variable named line thickness, and set its type to float. This determines how thick each line of the crosshair will be. Add another variable called center.size and set its type to float. This controls the size of the center dot that appears in the middle of the crosshair when it's enabled. Create one more variable named center.dot and set its type to Boolean. This determines whether the center dot should be displayed. Set the line length to 8. Set the line thickness to 1. Set the center dot size to 2.4, then enable center dot. Now, go back to the content drawer, right-click, and create a new widget blueprint. Name it WBP_crosshair, then open it. Inside the widget, get the canvas panel, then add an image to it. Name this image img_top. Set its anchor to the middle of the screen, then set its position X to 0 and Y to -16. Set the size X to 3 and Y to 14, then set the alignment to 0.5. Duplicate image top and rename it to img_bottom. Set its position X to 0 and Y to 16, keep the size the same as the top. Duplicate the image again and rename it img_left. Set its position X to -16 and Y to 0. Then set the size X to 14 and Y to 3. Duplicate the image again and rename it img_right. Set its position X to 16 and Y to 0. Duplicate once more and name it img_center. Set its position X and Y to 0, then set its size X and Y to 3. In the brush settings, set draw as to rounded box. Next, go to the event graph and create a new function named update crosshair. This function will be responsible for updating the crosshair whenever the state or style values change. Add an input named state and set its type to st_crosshair state. Then add another input named style and set its type to st_crosshair style. Once both inputs are created, right-click each input pin and choose Split Struct Pin. This lets us access the individual values inside each structure. Drag an img_top, then drag from it, and add a Set Visibility node. From the visibility input, create a select node. This select node will decide which visibility value should be used based on whether the crosshair is visible or not. Set the true value to visible and the false value to hidden, then connect state is visible to the index pin. This means that when is visible is true, the image will be shown, and when it is false, the image will be hidden. Duplicate these same visibility nodes for the other crosshair images. For the center image, duplicate the select node and connect it to the img_center visibility input. Then, from state is visible, create an and Boolean node. Connect the second input of the end node to style center dot, then connect the output of the end node to the index pin of the center visibility select node. Drag an img_top, then drag from it, and add slot as canvas slot. From the return value, add a set position node. From the in position pin, create a make vector 2D node. Right-click and get the state input. Take current spread and multiply it by -1, then connect the result to the Y value of the make vector 2D node. This moves the top image upward as the spread increases. We use -1 because negative Y values move the widget upward on the canvas. Duplicate the relevant nodes and change the image reference to img_bottom. This time, connect current spread directly to the Y value. This moves the bottom image downward as the spread increases, creating the vertical expansion of the crosshair. Duplicate the setup again and change the image reference to img_right. Connect current spread to the X value. This moves the right image outward to the right as the spread increases. Duplicate the setup again and change the image reference to img_left. Connect the multiplied current spread value to the X value. This moves the left image outward to the left, using the negative spread value so it moves in the opposite direction. Duplicate this setup one more time for img_center. The center image should remain positioned at the middle of the crosshair. Next, drag an img_top, then drag from it, and add slot as canvas slot. From the return value, add a set size node. From the insize pin, create a make vector 2D node. Right-click and get the style input, then split the struct pin if it is not already split. Connect line length to the Y value, and connect line thickness to the X value. Duplicate the relevant nodes and change the image reference to img_bottom. Connect the insize pin to the return value of the make vector 2D node. This gives the bottom line the same size as the top line, keeping the vertical parts of the crosshair consistent. Duplicate the relevant nodes again and change the image references to img_left and img_right. For these horizontal lines, connect line length to the X value, and connect line thickness to the Y value. Duplicate the setup one last time and change the image reference to img_center. Connect center.size to both the X and Y values of the make vector 2D node. This keeps the center dot perfectly in the middle and allows the size to be controlled from the style structure. Next, return to the content drawer, right-click, and create a new blueprint class. Choose Actor Component as the parent class, rename it to BPC_crosshair, then open it. This component will contain all of the crosshair logic and can easily be reused on any character. Start by creating a variable named owner character, set its type to character object reference, and mark it as private. This stores a reference to the owning character. Create another variable named owner movement component, set its type to character movement component object reference, and mark it as private. This gives us quick access to the character's movement state. Next, create crosshair widget ref, set its type to WBP_crosshair object reference, and mark it as private. This stores a reference to the crosshair widget after it's created. Create another variable named crosshair widget class, set its type to WBP_crosshair class reference. Enable instance editable, and set its default value to WBP_crosshair. This makes it easy to swap the widget class without changing the component. Create a new variable called base spread. Set its type to float, enable instance editable, and set its default value to 35. This is the default spread of the crosshair before any movement or gameplay modifiers are applied. Create another variable called movement spread add. Enable instance editable, and set its default value to 100. This value is added to the crosshair spread while the character is moving. Create a new variable called airspread add. Enable instance editable, and set its default value to 35. This additional spread is applied whenever the character is in the air. Create another variable called max spread. Enable instance editable, and set its default value to 150. This defines the maximum amount the crosshair is allowed to expand. Create a new variable called expansion speed. Enable instance editable, and set its default value to 8. This controls how quickly the crosshair expands toward its target spread. Create another variable called recovery speed. Enable instance editable, and set its default value to 6. This controls how quickly the crosshair returns to its normal size. Create a new variable called current spread. Set its type to float and mark it as private. Create another variable called target spread. Set its type to float and mark it as private. Create a new variable called isInAir. Set its type to Boolean and mark it as private. This tracks whether the character is currently airborne. Create another variable called isMoving. Set its type to Boolean and mark it as private. This tracks whether the character is currently moving. Create a new variable called state. Set its type to st_crosshair state and mark it as private. This structure stores the current runtime state of the crosshair. Create one last variable called style. Set its type to st_crosshair style, then enable instance editable. This lets you customize the crosshair's appearance directly from the details panel. Create a new function called calculate target spread. Drag an owner character and get velocity from it. From the velocity return value, get vector length xy. This gives us the character's horizontal movement speed without including vertical movement. From vector length xy, drag out and add a min float node, then drag from that and create a select node. Set the index type on the select node to Boolean. This setup lets us choose which speed value should be used depending on whether the character is actively accelerating or not. Drag an owner movement component and get max walk speed from it. Connect max walk speed to the B input on the min float node, and also connect it to the true input on the select node. This means the character's speed will never go higher than the max walk speed when calculating movement spread. From owner movement component again, get current acceleration. From the return value, get vector length xy. Then drag out and add a greater node. Set the comparison value to 1, then connect the result to the index pin on the select node. This checks if the character is actually trying to move, rather than only sliding or being pushed by physics. After that, drag out and create a map range clamped node. Set in range A to 100 and in range B to 900. Connect movement spread add to out range B. This converts the movement speed into an additional spread value. Drag in base spread, then create an add node from it. Connect the return value from map range clamped into the next input on the add node. Add one more pin to the add node, then from the new C pin, create a select node. Connect isInAir to the select node's index, and connect air spread add to the true value. This adds extra spread only when the character is airborne. After the add node, create a clamp float node. Connect base spread to the min value. And connect max spread to the max value. Then connect the clamped result into the function's return node. This ensures the final target spread never goes below the base spread or above the maximum spread. create a new function called Refresh Crosshair. Start by calling Calculate Target Spread, then set target spread using the return value. This updates the target spread every time the function runs, so the crosshair always reacts to the character's current movement state. Next, set current spread. From the value input on set current spread, create an finterp to node. Connect current spread to current, and connect target spread to target. Set delta time to 0.02. This smoothly moves the current spread toward the target spread instead of snapping instantly. From interp speed, create a select float node. Connect expansion speed to A, and connect recovery speed to B. Then drag in target spread and current spread, connect both into a greater node, and connect the result to pick A. This makes the crosshair use the expansion speed when the target spread is greater than the current spread, and the recovery speed when the crosshair is returning back down. From current spread, create a make st crosshair state node. Then set state and connect the new st crosshair state value into it. This packages the current spread into the state structure so it can be passed into the widget. Drag in crosshair widget ref, then call update crosshair from it. Connect state to the state input, and connect style to the style input. This sends the updated spread and style settings to the widget, allowing the visual crosshair to refresh on screen. Now go back to the event graph. Right-click and get owner, then cast it to character and connect it to begin play. After the cast succeeds, set the owner character variable using the character reference from the blue output pin. From that same character reference, get character movement, then set owner movement component and connect it. This stores the character and movement component as references, so the crosshair component can read movement information without needing to search for it every time. Next, drag in crosshair widget class and use it to create the widget. For owning player, get the player controller, then set crosshair widget ref using the created widget return value. After that, call add to viewport, then call refresh crosshair. This creates the crosshair widget, saves a reference to it, displays it on screen, and immediately updates it with the current state and style values. After that, add a set timer by event node. From the event pin, create a custom event and name it update movement state. Set the timer time to 0.02 and enable looping. This runs the movement update repeatedly so the crosshair can respond smoothly during gameplay. Inside update movement state, set is moving. Drag an owner movement component, get velocity. Then from velocity get vector length xy. From the return value, create a greater node, set the value to 100, and connect the result into is moving. This checks whether the character is moving fast enough to count as active movement. Next, set is in air. Drag an owner movement component again. Call is falling, and connect the result into is in air. This detects whether the character is currently off the ground, such as while jumping or falling. After updating the movement values, call refresh crosshair. This recalculates the target spread, smoothly updates the current spread, and sends the new values to the crosshair widget. To finish the setup, open your character blueprint and drag bpc_crosshair onto the character's components. Once the component is added, the crosshair system will run from the character automatically. You can also customize the exposed settings to adjust the spread, speed, and style until it matches the feel you want for your game. And that's it. The project files are on my Patreon if you want them, and since this plugs into any character, go watch my interaction system video next. Subscribe, and I'll see you in the next one.